previous video on significant figures looked at when you're taking the measurement yourself, where do you have to estimate up to? Where do you take your digits to? This one looks at what if we have a measurement, whether it's our own, one we've gotten from someone else, one we've done in the lab, one that's in a word problem. How do we know how many significant figures it has? So there's two rules for significant figures, which is that there's three rules. First rule, all non-zero digits are significant. Second rule, placeholder zeros are not significant, but others are. The third rule is exact numbers have infinite significant figures. So the first rule most people don't have any difficulty with. If it doesn't have any zeros, every digit is counted when we're counting significant figures. So 478 kelvins, the 4, the 7, and the 8 are all significant. We would say it has 3 sig figs. The placeholder zeros are not significant, but others are. It's broken into 3 sub-rules. So leading zeros are never significant. They're just there to hold things in the right place. Trailing zeros are only significant if the number has an expressed decimal point. And the third one, zeros between significant figures are significant. So these 3 rules, sometimes people get confused because they confuse significant with important. So leading zeros and trailing zeros are often important without being significant. So with those, our first one, 0.003, only has 1 significant figure. Those leading zeros are not significant. But they're important because they push that 3 into the thousands placeholder. So we need to know that it's 3/1000ths, not 3/10ths. That's important, but they're not part of the measurement. They're just putting that 3 into the right place. Likewise, in 0.024, those leading zeros are not significant, so there's only 2 significant figures, but they are important. Trailing zeros are only significant if the number expressed has a decimal point. So 172.00 kilometers, well, though the decimal and then the zeros behind it tells us this is significant down to the nearest hundredth of a kilometer. It's been measured very precisely. So it has 5 significant figures. Whereas 170 kilometers doesn't have a decimal expressed. It's only measured to the nearest 10. Right? It could be 170, give or take 10 kilometers. So it only has 2 significant figures. If I want to show 170 kilometers measured to the nearest kilometer, I have to put in that decimal point. So that decimal point there indicates that this is measured to the nearest kilometer, so it's actually 170, give or take 1 kilometer. So it's got 3 significant figures. So that decimal point makes a big difference there. Zeros between significant figures, usually pretty straightforward. We just count them all, right? So the 1, the 0, the 5, and the 4 gives us 4 significant figures. Likewise, 10.001 has 5 significant figures. Now, a technique that some people like to use is crossing out the things that are not significant when they're counting them. So if a number has a decimal, we start that crossing out method at the left, and we draw a line through any zeros at the start of the number. If the number has no decimal, we start at the right. So if we're looking at this first one has no decimal, we would cross out any zeros on the right. Well, that's zeros over here, but there aren't any, so we just end up counting everything. If it has a decimal, we start at the left. So here we would cross out these when we're doing our counting, and only the 3, right? We run into a 3 as our first non-zero digit. Likewise here, we've got a decimal, we start at the left. 172 has a decimal, so we also start at the left, and we run into that. No 0 here, we start at the right. So some people with this starting left or right, depending on the decimal, refer to this as the Atlantic Pacific rule, and it's an acronym, not an acronym, a mnemonic. So the mnemonic is Atlantic is absent. So if it's absent, we start like we would on the map on the Atlantic Ocean side of Canada. So or of North America. So the Atlantic Ocean, right, we start over here. Swim through the Atlantic till we reach land or a non-zero digit. If it's present, we start from the Pacific and we swim from the Pacific side till we reach a non-zero digit. Right, so these two, it would be present. We're swimming from the Pacific. So it's just a little technique. Some people like to use it. If it helps you with your counting, by all means, use it. Second note here is that zeros at the end of a number are sometimes, but before the decimal point, are sometimes what we call ambiguous. We can't tell if they're part of the measurement as written, right? So if we have something like 200 degrees Celsius, it could be precise to the nearest 100 degrees, could be precise to the nearest 10, could be precise to the nearest degree. If we write it in scientific notation, 2.00 times 10 to the 2, there's no doubt. In scientific notation, every digit shown is going to be significant because we have that decimal present, right? If we're using that Atlantic Pacific rule, we're crossing out the stuff from the Pacific side, so the 2, the 0, and the 0 are all significant. So we can see it's precise to the nearest degree. A second method that's sometimes used is to put a line over the 0 that's the last significant figure. Note that this line is different than when we have a line over something after the decimal. After the decimal, that's used to represent repeating decimals. Before the decimal, it's used to represent our last significant figure. So it has a different meaning even though it is the same symbol. And as I mentioned, our third rule, exact numbers have infinite significant figures. So exact numbers are things that are done either by definition or things that we count. So conversions are by definition, constants are by definition. So when we have things like metric conversions, 1 milliliter equals 1 centimeter cubed, or constants like pi, which we often estimate to a certain number of significant digits, but does not actually have an ending point. So if we look at the examples here, how many significant figures we have in each of the following. This one's got a decimal present. We would cross out anything from the Pacific side, so there's 5 significant figures there. This one, no decimal present, so those zeros don't count. We have 3 significant figures. Decimal present, start from the Pacific side, we've got 1 sig fig. Similarly, we cross out those leading zeros. We've got 2 sig figs on this one though, because we have a 0 at the end. 12 boxes is a little tricky because this is something we count, not measure, right? We don't have approximately 12 boxes. We've counted them. We've got 12 boxes. So this is one of the infinite ones. So we can use that infinity symbol to show that it's got infinite significant figures. Or another way you could say that, you could say it's an exact value. As compared to 12.0 meters, that one's measured to the nearest tenth, right? It's got a decimal, so it's got 3 significant figures. 480 kilograms, trailing 0, no decimal, so that 0 is not going to count, right? Absent decimal, go from the Atlantic, so we've got 2 significant figures. Last one, same thing, absent decimal, go from the Atlantic, we've got 3 significant figures. So that's how we count the significant figures. The next video will be on how do we use those significant figures when we're doing calculations.